We are continuing with rotations. Today I want you to talk about quickly, all right, about rotations about the origin. The origin meaning, what if your point is rotated around just 0, 0? You do not have to use a compass or a protractor if all of your rotations are happening around 0, 0. So there's 3 different rotations we're going to talk about, okay? We're going to talk about a 90-degree turn, a 180-degree turn, and a 270-degree turn. Now, each one of these turns that we're talking about is going to be counterclockwise, okay? So I want you to understand the direction we're going is counterclockwise for each one. Now, this is something you might want to place into your journal so that you have these in case I give you a question about turning a point or a triangle or something around the origin, not just any random point. We're going to talk about these 3 rules. We're going to talk about a 90-degree, 180, and 270. If you have an x and a y coordinate, and you wanted to make a 90-degree counterclockwise turn about the origin, you would simply switch and make it a negative y, comma, and x. All right? So what in the world does that mean? We're going to do an example. Okay? So I'm going to do an example. I'm going to do a point right here. Now this point right here is at a 3 and a positive 1. If I wanted to do a counterclockwise rotation of this point, I'm going to call it point A, then I am going to go negative 1, positive 3. Negative 1, positive 3. And this would be considered my A prime. Now how did I come to that? Because what is my x value? My x value was a 3. What was my y value? A 1. If that says negative y, that makes that a negative 1. And if I put an x there, that's still a positive 3. Now, I know it's kind of hard to see, so I'm going to try to draw it out so you guys can see what I just did there. Here we go. From the origin to A prime. What kind of angle does that look like? It's a right angle. All right? And if we took our compass, I know we don't need it, but if I put a point right there, and I put it right there, look what I did. I went which direction? Whoa, I didn't mean to do a whole circle. I just want to, it's really getting frustrating right now, because I don't want to do the whole circle. What am I trying to do here that I'm failing? I'm trying to arc it, right?
Right.
From there,
Cool.
to there.
It's like it's almost like we have over there. What? Can I ask what program you use to do that thing that's WS? That whole bar. What?
That's what's workspace? It's Interwrite. Interwrite's the company. Interwrite.
Does it cost money?
Yes.
I
I can't say. Okay. No, it's not super expensive. Okay, but you need to have a board that you can write on. So the software is much better. It's much better. You don't have to have this board. But right now, can everybody see how this direction is going counterclockwise? I went from here, and I'm just kind of drawing arrows going over. Okay. So that's your rule for 90 degrees counterclockwise.
90 degrees of a quarter circle, right?
Yes, quarter circle. Okay. Keyword counterclockwise. It's not clockwise. Next rule. Here we go. We're going to change it up here. I'm going to change it. I'm going to go green. All right. And I want you to understand the next rule is going to be a negative x and a negative y. So I'm just going to choose a random point, say right here. What point is that? That's over 4 and down 3. So over 4 and down 3. If I was going to use this rule, then I have to make the opposite x value, which is going to make that a negative 4 and a positive 3. So if I go negative 4 and up 3, I'm going to call this b. I'm going to call this b prime. And you should be able to see that this goes from here to right there. So it starts here and it goes all the way here. Can you kind of see how that would make a whole half of a circle? I don't want to confuse you. It's not a whole, it's half of a circle. But from here, if I stretch this out right from here to right there,
Almost. That's just human.
yeah, that's just human error. That's just human error. But can you guys see how that turned how many degrees?
180.
180. And it's still going which direction? Counter clockwise.
I mean, clockwise.
Right. But clockwise is the same place. Okay? Now, the last one I think is the most interesting because it's going 270 degrees counterclockwise, which is the same as saying 90 degrees clockwise. Just like this is the same as saying 180 degrees clockwise. This is the same as 270 degrees clockwise. Okay? So 90 degrees clockwise. Here's the rule. We're going to change colors right here. Alright? The rule is going to be a y and a negative x. So I'm going to choose another point right, let's say, right here. And what's that? I'm going to call this point C. So that goes what? Negative 3 and a positive 1. So if I wanted to turn this 270 degrees counterclockwise, what's going to be my new point? I have a negative 3 and a 1. What's negative 3 and a 1 going to become? A 1, positive 3. A 1 and a positive, which is going to put me right, unfortunately, right here. That's C prime. So I started here, and where did I finish? I finished right there. Now, what did I say that was going to be? A 270 degree counterclockwise turn, but that's the same as a 90 degrees clockwise turn.
So it's the 90 degrees counterclockwise and the 90 degrees counter.
That's going to be 270 degrees clockwise.
Yeah, like both of them put together. Like
Yes, they have to add it up.
reflected.
They have to add up to 360. Okay. Apparently, I can't get this color.
Well, just 90 degrees looks like it's reflected from the other one.
Yeah. So right here, can you guys see that this is 270 degrees going counterclockwise? But that's the same as doing what? That's the same as just taking that same thing and doing 90 degrees clockwise. So these are the 3 rules that you need to have in your journal. Okay? We can't use those rules on problem number 3 or problem number 4 because our point is not at 0, 0. Where is it at? It's at 1, 0. So we have to use our compass and protractor. But you know what we're going to do? We are not going to use our compass and protractor right now. We're actually going to use some logic. We've done the compass and protractor yesterday. So what I'd like you guys to do is I would like you guys to just visualize right now. If I wanted to rotate point T, and I wanted to rotate it clockwise, how many degrees? We're supposed to do clockwise 90 degrees. Okay? It tells us, it's kind of hard to see, but it says, I'll zoom out so you can see it real quick. See, it says, draw the rotation image of each figure 90 degrees in the given direction about the center point 1, 0.
That would be
All right? So just use some logic.
3, 0, right?
It will be. If I go 90 degrees, watch. 90 degrees puts me right there. Clockwise. So what's that point right there, everybody? That's going to be T prime.
Can we do that?
Yeah. The next thing I'm going to do is I'm going to draw a line from P to S. So go ahead and draw a line from P to S. Okay? By the way, we're going to use the concept of negative reciprocals to help us out. Just remember, what do negative reciprocal slopes create? There's got to be one person in here that knows what negative reciprocal slopes create. 90-degree angles. They make perpendicular lines, and that's what we're trying to do. Why are we trying to make perpendicular lines? Because that's actually what? Dealing with 90-degree angles. So would you guys look from P to S? What's the slope? How much does it go up? It goes up 4 and over 1. Up 1, 2, 3, 4, and over 1. What would be the perpendicular slope? It's going to be a negative 1 over a 4. So from here, I want you to go down 1 and over 1, 2, 3, 4. Put a point and call it S prime. If you can't see the right angle, maybe you can see the right angle now in green. If you still can't see the right angle, that's okay. I'll get out my protractor, and you can see how that protractor should fit right in there. Can you see how it slides perfectly right in?
So we need to draw a line between.
Well, what I want you to do is I want you to draw a line to PS and from P to S prime. That's your S prime. Here's the last one. I'm doing it orange. Hold on. Let's check it out. Goes down 3 and over 4, right? So that's a negative 3 over a 4. See how this goes? Down 3 units and over 4 units. So what would be the perpendicular slope? Yes, I have a pencil.
It'd be 3.
Yes, I will.
3.
The negative reciprocal. That makes it say, if it's negative, it's... And what's the reciprocal of 3 over 4? 4 over 3. By the way, negative reciprocals are basically, you're not going to see this in the math textbook. They're called flipping opposites. You flip them and you make the sign the opposite of what it is. It's almost like you get to math class. Say it. Flipping opposite. That's what negative reciprocal slopes are. They're the flip and they're the opposite. It's ridiculous. Now, from here, you're going to go up 4 units and over 3. Right here. Go up 1, 2, 3, 4, over 1, 2, 3. Put a point. That point right there is going to be your R prime. I'm drawing it so you guys can see the right angle that's been created. Can you guys see how all of these have been rotated how many degrees? 90 degrees. If you still don't believe me while you're doing this, you should be able to see that this protractor, once again, should be able to perfectly slide right in there and make a 90-degree angle, okay? And it's going clockwise. So please finish your triangle by connecting what? R prime to T prime to S prime, and then shade it in gently. Make it precise, make it accurate. Take the time and energy to do the job right. Number 4, it's a little bit different. Number 4, we're still doing a 90-degree turn. But on number 4, we're not going clockwise, we're going counterclockwise, which means we are not going to be going as the clock turns, we're going to be going the opposite direction, which means we're going to be going this way. Okay? So let's just use the same strategy, okay? Same strategy. Right now, we are dealing with these points. So we're going to start right here at K. So I'm going to draw a line from P to K. Now I have a choice. Do I want to go clockwise? Do I want to go clockwise? Or do I want to go counterclockwise?
Counterclockwise.
I'm going to be going this direction right here. Okay? So what I'd like you to do is look at the slope of P to K. What's the rise to the run? How much does it go up? It goes up how many? And over? So put up 3 over 2. Right here, what's the perpendicular slope to that if we're using negative reciprocals?
You're going to go negative 2 over 3.
There we go. So what we're going to do right here, we're going to go down 2, right? From here, we're going to go down 2 and over 3. Right? And what is this point right here going to be? That point's going to be K prime. Changing colors. We're going to go from P to J. From P to J. So right now, let's think about that slope. That goes down 1, 2, and over 1, 2, 3, 4. So that goes down 2 and over 4. I'm not going to simplify it to negative 1/2 because I don't need to. What's the perpendicular slope of a negative 2 over a 4? A positive 4 over 2. So if it's negative, it becomes positive. If it's positive, it becomes negative. And then you flip it. So what am I going to do? No, it's just basically, it's a negative reciprocal. If that's a plus, that's a minus. If that's a minus, that's a plus. And then you flip, you make the reciprocal of the number. Now, from here, what am I going to do? I'm going to go up 4 and over 2. And what is this point going to be right there? That's going to be J prime. Now I'm going to go green. From this point to H. We have to take a very close look at this slope. It goes up 1, 2, and over 1, 2, 3, 4. So that goes up 2 and over 4.
So that's going to be negative 4.
So negative 4 over 2. All right. Now this one you got to think of it a little bit different. Okay. This one we remember if we're doing it this rotation, we're going counterclockwise. That means we have to go which direction? We have to go over here. Okay? So what we have to do is you're going to go over 2 and up 4. You're like, wait a second. You said negative 4 over 2. But you know what you can also do? You can also go up 4 and negative 2 to the left. That's the same. So you go from here to right here. Well, here I put a plus.
Right.
That just stays, right? Here I could do a negative 2 and a positive 4, or if I wanted to, just, if I wanted to, if I felt like it, I could keep that as a plus and keep that as the same thing.
What is that?
By the way, it's either a negative 4 over a positive 2 or a positive 4 over a negative 2, so it stays negative. Oh, this right here, that's H prime. Oh. The question is this: can you see that you made the correct angle going from here to there? Can you see how that was arced going? Which direction going? Counterclockwise. Okay? So, here's our final triangle that you're going to color in. We're going from H prime to what? And from J prime to? Right there. You gotta find your primes. Connect the dots. And with all the lines and stuff that you drew, you have to make sure that you label the prime so that you can shade this in. Nice. And shading in the final result. You guys should be able to shade in it a little bit neater than this highlighter right here, okay? And that's your final answer. Next thing we're going to talk about, what I'd like you to do in your journal right now, I'd like you to make a circle. All right? And I would like you to put like a cross through it like that to the best of your ability. Yeah, make like a crosshairs, okay? You do that?
How big is it?
That doesn't have to be that big, okay? We're going to be talking about the concept of, this is just an example, so this is not dealing with a specific answer to a problem. You're going to need to know this to help you solve number 5.
Put it in our journal or in our...
Oh, no, yeah, journal.
Journal?
Journal. So I'd like you to put it in your journal. Good.
Oh, so I think I just made 2 videos.
Okay, we're going to be talking about the concept called rotational symmetry. Now, I've just drawn a circle and I've drawn a little cross through it, okay? Now, think about this. How many times could I turn this cross right here and it look exactly the same? 4. 4.
Yeah, 4.
Infinitely, right? But typically you have 4 turns where, you know, that if I labeled this like A, B, C, D, that if you didn't know that, you wouldn't realize it. So everybody, that's what rotational symmetry is. Like, how many times can you turn it without people really noticing that it's turned? Okay? Like, if you grab it right here, let me get the hand. Let's say I grabbed this part right here and I moved it right up there. But you guys didn't notice it. You wouldn't notice that I turned it unless you saw me turn.
Like if you had a circle and it was turning, but you can't tell it's turning.
Right. Okay? So right now, how many times could we turn it? We have an order of 4. That's what the order is. That's what the word order means. You have 4 different ways you could turn it, and it would look exactly the same. Okay? Now the magnitude. The magnitude, how many degrees are always going to be in a circle? 360. So each one of those turns that we would make would be a total of 90 degrees. Every turn is a 90-degree turn. From here to there, you can clearly see is 90 degrees. Okay? So this is an example of order and magnitude. Now imagine, if you would, a paddle wheel on a steamboat is being driven by a steam engine that rotates paddle. You guys know what a steamboat?
Yes, sir.
It kind of looks like that, except there's a heck of a lot more paddles, right? When I say it looks like that, I mean it looks like this, just with a lot more paddles. So, if it has how many paddles evenly spaced? 18. So if they're evenly spaced, I want you to know that's the order. The order is 18. But it says, what's the magnitude? The magnitude is going to be 360 degrees divided by the order, which is 18, which is going to make it 20 degrees. So it's only 20 degrees between each one of the paddles. Yeah, so 20-degree turns. Okay? Now, using that concept, it says, in figure 6, describe the rotation that moves triangle 1 to triangle 2. Now imagine if you were to grab this right here, and you were able to slide it over 1. And every time you slid it over into the space, you made it click. So right here, that'd be a click. Here, another click. Here, another. So if you like turn it, you go click, click, click. How many turns would it take? 3. So right now, we have 3 turns. Now which direction was I going? I was going which direction?
Clockwise.
Clockwise. So 3 clockwise turns. Now, by the way, does anybody know what the order is of this figure? How many even spaces all the way around? An order of what? 8. Which means, I'm going to write the word mag, short for magnitude. If you took 360 degrees and divided it by 8, that would give you a total of 45 degrees. So each turn is how many degrees?
45 degrees.
So you have 3 clockwise turns at 45 degrees, which means you could say, you know what, Mr. DeMoon? If you turned it 135 degrees clockwise,
It would equal to.
it would go from 1 to 2. But that's not the only direction you can go. You can always go counterclockwise and get the same result.
Farther.
It's just a little bit further, all right? This is like when some people go to college and it takes them less time than others, but they still graduate. I had a friend, took him 7 years to graduate college, all right? And I said, shouldn't I call you doctor? He's like, no, it just took me a long time. So, by the way, still 45 degrees, right? How many turns, though? 1, 2, 3, 4, 5. So you'd have to do 5 times 45. Now, by the way, the clockwise and the counterclockwise should add up to a total of
360.
yes, 360. So this would have to be 225 degrees. That's what 5 times 45 is. Counterclockwise. Okay, everybody, we only have one more problem, and the rest of the assignment you're responsible on your own. Because what have I already defined? I've defined order and magnitude. So I am skipping problem number 7 because it says what is the order. So guess what? You don't have to. It's pretty easy. But right now we are going to do problem number 8 because problem 9, 10, and 11 are dealing with what? Order and magnitude, which we just covered. So
What should you record this?
I am recording it right now. Literally, you're being recorded right now. You see the time? So right now, what I'd like you guys to find out on problem number 7 on your own, even though it says just order, put order and magnitude just so you can test yourself. I don't know why my board's not working. Probably because it knows it's about to end the day. So right now, find the what? Find the order and magnitude. So here's what we're going to do. We are going to do 2 things on problem number 8. The first thing we're going to do is we're going to go across y equals 0. The second thing we're going to do is we're going to go across y equals x. So what I'd like you to do on your paper is I'd like you to draw a line right here at y equals 0 and label it y equals 0. And the next thing that I would like you to do is draw the line y equals x. And be very careful as you draw this because if you mess up, it's not going to be y equals x. Y equals x should go up 1 over 1, up 1 over 1, up 1 over 1, and it keeps going on forever, up 1 and over 1. So there's your 2 lines that you're going to be reflecting across. Now, what we're going to do is we're going to choose a random point. We are going to choose a point. I'm going to call this point right here. I'm going to call that point A. That's point A. First thing, what do I want to reflect it across? Y equals 0. So watch where I go. 1, 2, 1, 2. Put a point right here. Label that point A prime. The next thing I need to do, after reflecting across y equals 0, what do I need to reflect it across? Y equals x. So let's count how many diagonals it takes me to get to y equals x. 1 diagonal. 2 diagonals, 3 diagonals. You're like, what the heck are you doing? You guys see how I'm going across these square units? How many diagonals would I have to go across? 1, 2, and 3. I know those horrible straight lines, I'll erase them. So if I go from right here, how much do I have to go down? 3 diagonals. 1, 2, 3. Right
I did it
there.
in the wrong order because it's the right way.
This is a double prime. Why do I call it a double prime? Because that's my second transformation. That's my second move. If I did a third move, I'd call it a triple prime. I might be a superhero one day. You never know. Okay. So, let's think about this. Check this out in green. Where did I start from? I started right here. And where did I end up? I ended up right there. Now, what I want you to do, I started there. I ended there. It says describe, before you ask questions, it says describe this rotation. It says the net effect is a rotation of the object. So what I want you to do is to describe in your own words what is another way of getting from point A to point A double prime, describing it as a rotation. Hey, listen up. Do you guys see which direction it's going? Is that going clockwise or counterclockwise?
Counter.
Your answer is a 90 degrees counterclockwise rotation. Do not move. Be quiet, please. That is your final answer. The rest is on your own.